Welcome today to this lesson. This is chemistry made easier. Chemistry practical made easy to understand. I want to welcome you once again. Let us look at this question. You are provided with solution A, which contains 3.56 grams of HCl per liter. Solution B contains 6.3 grams of this acid per liter of solution, sodium hydroxide solution C. So here, before we move on, you need to understand that solution A contains 3.56 grams in 1 liter. So it is important for you to note that 3.56 is grams per liter, because it is important to note that. Also, solution B contains 6.3 grams per liter. Very important to note. What are you required to do? To standardize solution C, determine the value of N in the formula of this acid. Procedure: place solution C in the burette using a pipette. Transfer 25 centimeters cube of solution A into a conical flask. Add 2 drops of phenolphthalein indicator and titrate with solution C until a permanent change is obtained. Record your results in the table 1 below. Repeat the procedure to get 3 readings. So we have been given the values for the table. We have 25, 24.9 and 24.9. So what we do here is to get the average volume. So I've always insisted, always remember and try to understand what is reacting. So C is reacting with A. Then you must go back and try to know what is C. C is sodium hydroxide. A is HCl. So that you are able to understand. So it means this is a neutralization reaction. So let us see the average, determine the average volume of solution C used. The average volume, so we get the average 25 plus 24.9 plus 24.9 divided by 3, which is going to give us 24.93 centimeters cube. That's our average. Calculate the concentration of solution A in moles per liter. You have given the hydrogen is equal to 1, chlorine is equal to 35. So we want to calculate the concentration of solution A in moles per liter. Whenever you are asked to calculate concentration in moles in 1 liter, that is what we call molarity. So they want us to calculate molarity. So how do you calculate molarity? Molarity is equal to mass in grams per liter divided by RFM. Maybe if this is the first video you are seeing, there is a table I've been giving that I draw like this. For those who have seen it for the first time, we have molarity, mass in grams per liter, and then RFM. So whenever I want to calculate RFM, it is mass in grams per liter over molarity. If I want molarity, it is mass in grams per liter divided by RFM. So that's what we are doing here. So solution A, the mass that was used to prepare solution A was prepared by 3.56 grams in 1 liter. So we have that 5. So 3.56 divided by RFM. RFM, this is chlorine. So not chlorine, HCl. HCl. So this is 1 plus 35.5, which is 36.6. This one is going to use your calculator, and it will give you 0.09753 capital M. Okay, calculate the concentration. Calculate the concentration of C in moles per liter. Calculate the concentration of C in moles per liter. So go back. You are provided with C. There's now, there's now, we don't have any much information about C. But now we can get the number of moles of C, and from there we will get the concentration of C. C is sodium hydroxide. This is C. It's reacting with A. A is HCl, which is going to give us sodium chloride plus water. Sodium chloride plus water. So the ratio is 1:1. But now we know the concentration of A. We know the concentration of A. So 1,000 of A contains this. So we can get the number of moles of A that reacted with sodium hydroxide. Yes? Yeah, now that's where we begin. We have the concentration of A. We know the volume of A that was used. A, we pipetted 25. Transfer 25 here. 25 of solution A. So 25 solution A reacted with 24 solution C, 24.93. So here we will say 1,000 centimeters cube solution A contains 0.09753 moles. This is molarity, which is the number of moles in 1 liter. Then now we will ask, what would be the number of moles in 25 centimeters cube of solution A? Now we will get that. So it is 25 times this and then divided by 1,000. That one will give you 0.022438. Right? Now we have the number of moles of solution A. But solution A reacted with solution C, but the ratio is 1:1. So since mole ratio equal to 1:1, then moles of C equal to moles of A. That is 0.002438. Right? So we now have the number of moles of C, 24.93 solution C. This is the number of moles of 24.93 centimeters cube. So the question is, what will be the number of moles in 1,000? Because we are asked to calculate concentration in moles per liter. That is molarity. So we are going to say 24.93 centimeters cube of C contains 0.002438. This one. 1,000 centimeters cube solution A will contain what? So it is 1,000 times this number of moles divided by this. That one will give you 0.09761 capital M. That is the molarity of solution C. Let us go to procedure 2. Wash the pipette and the conical flask. Pipette 25 of solution B and transfer it into a conical flask. Add 2 to 3 drops of phenolphthalein indicator and shake. Titrate this solution against solution C in the burette. Obtain 3 readings and record your results in table 2 below. So here, sodium hydroxide, which is solution C, is reacting with acid B. B is an acid, but we know it is an organic acid. It seems to be an organic acid. So let us go to table B and see the information that we are given. So we have the table field. So we have 24.9, 25, and 25. So let us calculate the value. This is the solution C that was used. Volume of solution C. Remember, we pipetted 25. B was pipetted 25. That's why I say that it is important for you to understand the procedure. Solution B, pipette 25 of B. So B is the one we use 25. We are going to obtain the volume of solution C from titration from the table. It is important to know that. So the average, it is 24.9 plus 25 divided by 3. This one is going to give us 24.93. So this is 25, which is going to be 24.97 centimeters cube. Calculate the number of moles of sodium hydroxide contained in the average volume. This number of sodium, but we know the concentration of sodium hydroxide solution C from our previous here. We have the concentration of solution C. So we will say if this is the number of moles in 1 liter, 1000 centimeters cube, what about the one we have gotten there? So 0.09761 is the number of moles which are in 1 liter. What about the volume? Here is 24.97 centimeters cube of that solution C. This volume times this 24.97 times this number of moles divided by 1000, and that one will give us 0.00237 moles. So that is the number of moles that were used here. Calculate the moles of acid B contained in 25 centimeters cube of solution B. Now, then another thing now here we want to know or to understand is whether the acid B was a diabasic or monobasic. Once we know that, then we will know the ratio. We will be able to know the ratio. Acid B, or solution B, contains this. Now look at this. 2 times 2. This one is a diabasic acid. There is 1 hydrogen here and then there is 2 outside here. So 2 times this is a diabasic acid, and a diabasic acid is a good example of the common acids we know is sulfuric acid. So it's like now we are reacting sulfuric acid with sodium hydroxide. We know what will happen there. Now B versus C. Since this one is a diabasic, this one the ratio is going to be 1 to 2. The ratio is going to be 1 to. If you are wondering how, for example, let me use something here: sodium hydroxide plus sulfuric acid. The one we know because it is a diabasic like sulfuric acid. What we are going to get is sodium sulfate plus water, isn't it? We are going to put it to here. So the ratio is for the base and the acid is going to be 1 to 2. So this being a diabasic acid, the ratio, 2 to 1. 2 to 1. B being a diabasic acid like sulfuric acid, it will have 1, the ratio will be 1 and the base will be 2. That's what I have done. Now since we know the number of moles of C is this one, since we know the number of moles of C that was used, we can easily get the number of moles of B, because we will say if 2 equal to 0.002437, 1 will be what? So that one is a half times this. That's one will give us 0.0018. 58, 12, 18. Yeah, 12, 18. 0.001218 moles. So the moles of B is I have the moles of C because the ratio is 1 to 2. What is the concentration of B in moles per liter? Moles per liter. So we know this is number of moles in 25. 25 centimeters cube of B equal to 0.001 to 18 moles. 1000, which is a liter, will contain how many? So it is 1000 times it will go like this, 0.00128 divided by 25. So one will give us 0.0487 for capital M. So the molarity of solution B is that. Calculate the RFM of the acid. We want to calculate the RFM of the acid solution B. From this table, molarity, RFM, mass, grams per liter. So we have mass in grams per liter of solution B. We have the molarity of solution B, which is this one. RFM is what we are looking for. So then RFM is equal to RFM. We hold this one here as a constant. Then RFM is equal to mass in grams per liter divided by molarity. Mass, grams per liter divided by molarity. Where is the mass in grams per liter of solution B? You go back to what you are provided with. Solution B contains 6.3 grams per liter. So it is 6.3 grams per liter. We have the mass. So this one is 6.3 divided by molarity. Molarity of B is here, 0.04874. So when you use your calculator, you will get 129.3 and other. So this is grams. And that is the RFM. So we will approximate this one to be equal to 129. We assume 3.3. Determine the value of N in the formula. Remember our formula was COOH 2.N waters. So this is the form we want to find the value of this N. But when everything is added here, the total will be the RFM. When you add everything here, you will get the RFM, which is 129. Right? And then we have been given here, carbon is equal to 12, hydrogen is equal to 1, oxygen is equal to 16. So 1 carbon, that is 12, but there is times 2 here, times 2, plus 1 oxygen is 16. Here we have how many? 2 of them inside. So 16 plus 16, and then times 2, plus N into 1 plus 1, that is 2, plus 16, that is 18. It's equal to 129. So this is 24. This is 32 times 2, 64 plus 18N. So 64, I have left out hydrogen, plus hydrogen has got 1 times 2, 2. So we must not forget that, so plus 2. So add everything here will give you 90 plus 18N is equal to 129. So you like terms together. 18n is equal to 129 minus 90. 18n is equal to, it will give you that 9. Divided by 18, divided by 18. So n equal to 2 point something there. So you ignore the decimal points and n equal to 2. So the value of n in that formula is 2. Thank you for your time.